Hey everyone, so today for our Wednesday lesson we're going to do a little review over SohCahToa. So this is something you saw in geometry. It's this basic idea of trigonometry that we can relate the ratios of the sides of a triangle to their angle. And these ratios are consistent as long as we know that angle. It doesn't matter what size our triangle is, right? As long as we have a similar triangle, same angle, then we can define it using these ratios. So our lesson today is going to be around woodworking. So for Christmas this year, I made a gift that was a little wine bottle stand type thing. And in order to do this, I needed to cut a specific angle. But unfortunately, even though I am a math teacher, I don't own a protractor at home. They're all in the building. I don't have a compass either, so I had no way to measure this 40-degree angle I needed. But I was able to do it anyway. Without having an instrument to measure my angle, what I did have was a ruler and some basic knowledge of trigonometry. So how did I get this 40-degree angle? Well, what I did was just take a couple measurements and do a little bit of trigonometry. So thinking about a right triangle that with a 40-degree angle, I wanted to be able to relate the opposite side to the adjacent side. So I'm using tangent here, and I see that the tangent ratio for 40 degrees is 0.84. So what I was able to do is take this 2x4 I was using, and if you actually take a 2x4 and measure it, the width is not actually 2 inches, but 1.5. So my y distance, my vertical distance, was 1.5 inches. So in order for me to get a 40-degree angle, I need the 1.5 inches to be 0.84 times the value of that x distance. So with a little bit of math I can solve, and we'll see that 0.84 divided by 1.5 gives us 1.787. It's a little cut off there. So that's a little more than 1 3/4. Okay, so I'm going to go right between 1 and 12/16 and 1 and 13/16, right in there, and make my mark. So now what I can do is cut along that diagonal. So right along that diagonal, and I know that I have a little 40-degree triangle that I've created there. So without having the appropriate tools, without having to go back to the building and get a compass or get a protractor to measure this out, I can actually just do it with a ruler if I know the trig ratios. So now that I've got that measured off, I'm ready to cut at that angle and make a nice gift, right? And know that I have a 40-degree angle. So obviously I'd want to secure that board before I actually start cutting, but you get the idea. So without having to do any actual measurements, I was able to produce a pretty accurate 40-degree angle so I can make this thing balance really well. Cool. So we saw an example there where I took an angle, get to that in a second, took an angle that I knew I wanted, 40 degrees, and I could figure out how long I needed to separate these cuts, right? So I could cut that diagonal using a little bit of trigonometry. So my angle's right here, which means I'm dealing with the opposite side over here, the adjacent side over here. So according to SohCahToa, I need to use a tangent function. So tangent of 40 degrees is y over x. Okay? So I made this the width of my 2x4 here. I found out that y was about 1.5 inches. And then I can solve for x. So I multiply the x over x times tangent of 40, which is just some value, is equal to 1.5. So if I divide by whatever that is, I get x. So you want to be really careful when you're doing these trig calculations. You need to make sure that your calculator is in degree mode when we're dealing with degrees. So I'm checking that real quick before I throw this in. 1.5 divided by tangent of 40. And that's how I got 1.787. So I measured that 1.787 and was able to make a really accurate cut of 40 degrees. All right, another place that you might want to use trigonometry in woodworking is with dovetails. So dovetails are these fancy joints that we use in woodworking to join two boards together. And often we refer to these angles that we cut these dovetails at with their ratios. So for example, the most common one is a 1 in 7 cut. So what we mean by that, when we say 1 in 7, we're talking about essentially a tangent ratio. So if we think about the triangle that's created when we make this cut, 1 in 7 means that the short side and the long leg will have a relationship where the long leg is 7 times longer than the short leg. So essentially what we create here is a little triangle. So what if I wanted to make one of these dovetails and I wanted to use a protractor? I wanted to use something that'll tell me what my angle is. Can we actually figure out what the angle is? So before we solved the triangle, we solved for a missing side. We can also use trig to solve for a missing angle. So once again, we need to think about SohCahToa and figure out what angle we need. So SohCahToa helps us remember which trig ratio we need for the relationship we have. So if I'm looking at this angle right here, we don't need anything about the hypotenuse. We don't know anything about this length, and we don't really care. The side next to my angle, that's called the adjacent side, so we're using that. And the side across from the angle, that's called the opposite side. We need to know that as well. So we're trying to relate opposite to adjacent, which means we need toa, we need tangent. So SohCahToa tells us that tangent of an angle is equal to the opposite side divided by the adjacent side. I'll fill that in a second. The opposite side divided by the adjacent side. This symbol right here, that's a theta. That's just a symbol that means the angle. It's just like an x or anything else, just an unknown value. So we don't know the angle, but we do know those side lengths, 1 and 7. And actually, we don't really care what the actual lengths are as long as they have a ratio of 1 to 7. It could be 1 centimeter by 7 centimeters. It could be 2 by 14. Doesn't matter. If we divide them, it's the same value. It's just a ratio. Okay, but we have a problem here. Normally, we would throw this into our calculator, do tangent of an angle, but we don't know the angle yet. So we need a function that can undo tangent. We need an inverse tangent. Just like every other operation we've learned in algebra, there's always an opposite function. So for this one, we need inverse tangent. That looks like this. And we have a button for it on our calculator. You can see there the inverse tangent. So we're going to be using that. So if I take the inverse tangent of both sides, then I'll have something like this. Tangent and inverse tangent, those are opposites, so they're going to cancel each other out. We just get the angle is equal to inverse tangent of the ratio. Often when I'm doing these types of problems, we can kind of skip this step. It's a little formal to show this, but often I just remember that when I'm taking an inverse tangent, I swap out my angle and my ratio. So this becomes this. All right. So if I do inverse tangent of 1 over 7, we'll get 8.1. So our angle is equal to 8.1 degrees. And that looks about right. It's a pretty small angle. So this angle in here, 8.1 degrees. With angle measurements, it makes sense to round to the nearest tenth. We're not going to get much more accurate than that. All right, so I know this small angle is 8 degrees, 8.1 degrees. So we can also get the other angle over here as well, if we want. So we know that in total, the triangle has 180 degrees. So if we subtract out the right angle, 90 degrees, and we also subtract the small angle that we just found, 8.1, we'll find out this other angle is 81.9 degrees, which, if we're actually cutting this, might be more useful to know than the small angle, depending on how we're cutting it. Cool. So trigonometry can help us find missing parts of our triangle. If we know the side lengths, we can figure out angles. If we know angles, we can figure out side lengths. It works either way around. So one more thing we can do here, because this triangle's feeling a little bit unfinished. We know all 3 angles, and we know 2 of the sides. Can we go ahead and figure out the hypotenuse as well? We probably don't need to know that right now to cut this joint, but let's just go ahead and finish solving the triangle. So we actually don't need any sine or cosine to do this. All we need is the Pythagorean Theorem. So hopefully you remember this one. A squared plus b squared is equal to c squared. So another basic relationship we need to understand about right triangles tells us that a and b, those are the legs of the triangle. If I square those, that's going to be equal to the hypotenuse squared. So the hypotenuse is always c. So 1 squared and 7 squared should give me my hypotenuse squared. Okay, 1 squared is 1, 7 squared is 49. So c squared is 50, which means c is the square root of 50. That's about 7, a little bit more, 7.07. So the length of this last side, in case we need to know, is about 7.07. All right, so you're going to have a couple problems to work through for this async, finding missing sides and missing angles. Thanks, guys.